All right, so your Lab 0 Part 2 is due today. Make sure you check the deadline. I believe it's around midnight. Just make sure you submit in time to get your credits. Your lab number 1 was just released earlier this morning, so please get started as soon as you can. It's going to be a different format you want to get used to. So lab 1, 2, 3, 4, and 5. So they will be the same format as what you're going to experience in the actual programming test. So tomorrow I'm going to run some mock-up tests. So please go to your enroll session, which I believe will be like a 1 p.m., right? So just go there and I'll guide you about the process, okay? And the TAs will be there as well. So in the first roughly 40 minutes, we're going to do the mock-up test. And then whatever time that's left, we'll also have the TA there also to answer your questions. So if you've got any question about Lab 1 or even Lab 0, you can definitely stay to actually ask questions. You're more than welcome to. And programming test number 0 is going to happen next Wednesday, right? So tomorrow's mock-up test is optional. If you feel comfortable, you don't need to come, right? But I'll encourage you to come, just to experience what it is going to be like. But the guide for your programming test 0 is already on the web, so please check about the formats, expectation, grading scheme, etc. I try to put everything there as clear as possible. But if there's any confusion you might still have, you can reach out to me. We can talk, okay? And for last Wednesday, I believe I mentioned, just about the helper method in the lab demo. It's actually in the lecture site. All right, any questions about the course? Anything that's not clear about what's going to happen? Everybody good? Okay, so let's do a recap just about what we did last time, and then we'll continue with the coverage for the OOP review. We are including today, I think we just need 2 to 3 more classes to finish the review. So basically right before your programming test 0. But as I said, please don't wait for me. You should really go ahead and also study the slides, okay, and also the materials. It's something that I can expect you to have already known from the first year, so you definitely want to review on your own as well. Don't wait for me, okay? So last time we actually spoke about the data types, about primitive versus reference type. And today we're going to dive into the reference type more, especially how we can understand something called reference aliasing. And then, let me mention that right away, just before I forgot. Okay, so we are not going to reach for this exercise here, but we'll start with that on Thursday. So if you go to the lecture site, I think there's something I could have mentioned to you guys maybe earlier. Let me mention once more. So you can see under exercises, so there is one thing about tracing OO programs with reference aliasing and arrays. So I'll cover the definition and the basics about reference aliasing today. And then I'll also give you some preparation exercise as well. But I want you to really try this exercise here. The best way to do it will be print out the exercise on a piece of paper, will load to your tablet computer. That one nicely simulates what's going to happen in a written test, okay, or maybe the exam. So that's something I'll encourage you to try before I go over the solution with you on Thursday. Okay. All right, so primitive type, reference type, right? Just remember the reference type is really about storing address, but specifically for the type that's declared, all right? And then let's see what we have. Okay, we'll talk about null pointer exception, right? So whenever you have a dot notation, that means you want to look up the address that's stored in the context objects, right? Hey guys, please, all right? I'll really appreciate if you want to talk, please outside, okay? Please. So if you got a dot notation, so that means you want to look up the address stored in the context objects. If the address happen to be null, of course, you got null pointer exception, right? So we'll see more occurrences of that maybe a little bit later as well. But you want to really know the basic definition. And we did this little exercise here about multiple dots. So you ought to know about how many possible causes for null pointer exception and exactly what they can be. And that's something we did last time. So go over the exercise, and if I give you something similar or like slightly extended, so you should really know how to solve them. Right, just some general principle whenever you declare some variable type, okay? And then we talk about, I think one of you actually asked me about the difference between numbers and also address, right? So I would say they're simply different categories, right? So if you say numbers, they're simply just some value which you can do arithmetic. But if you talk about address in Java, you don't really add up any addresses together. All you do is you simply store the address in some reference variable so you can somehow compare to see if you're referring to the same objects. That's something I will elaborate a little bit more today, okay, when we do some tracing. And we distinguish between parameters versus arguments. Okay, just about parameters is when you try to declare methods, right, as part of the headers of the method, right? So you got inputs over here, Sometimes, of course, the method itself may not have any parameter. And also you got usages, for the method call. So any values you pass over here will be something called arguments. So it's a very important distinction between parameters and arguments. So when we talk about the equals method and also call by value, we will actually need to understand these two. I'll also revisit them. But for now, I think just understanding this example will be sufficient. Right, we talk about the scope of variables, in Java. So there are basically two scopes. Either it's at a class level, or it could be at a particular method level, right? So we went over the principle and some very simple exercise, but the best way for you to really dive deeper is to feel free to extend this example here and try it out on Eclipse. So Eclipse will be your best teacher to really tell you if you got any compilation error, if you make any errors in the variable scope. Okay. And that's a visualization we did just about object creation. However, this method here, very nice. It actually nicely connects to a little bit more hardware-oriented notation. But to really answer questions I'm going to give to you in the written test or exam, or even your lab, whenever you want to trace program, if you got any bugs, you don't necessarily have to always go to debugger. But sometimes maybe just on a piece of paper, you can trace the code already. This way here is not the way to go. It's not that efficient. So I'm going to show you some very systematic notation today, and then we'll do some exercise. But I'm going to use that notation throughout the course. So you definitely will get enough exposure to it. All right, so we talk about, like a different memory addresses, right? If you compare, for example, this address that's stored here and this address that's stored here, you can see they are different addresses, right? We are going to somehow relax this notation a little bit. So when you actually get to think about this kind of issues here about different objects in the memory, you can simply use arrows to actually help you actually visualize what's going on. I'll show it to you a little bit later today. Right, and then we distinguish also something very critical. So whenever you talk about assertions in JUnits, like a testing, it's either pass or fail. You don't say true or false. Similarly, for the Boolean expression, you only say true or false. You don't say pass or fail, right? So these two, but they somehow work together. So you want to review about assert true and assert false. And about different values for the arguments over here, you might get pass or fail accordingly, right? That's something we also talk about quite thoroughly. So I will encourage you to also review this part over here. And then I believe there's a last example we did just about calling mutators and also accessor. So the principle is the mutator returns void, what returns nothing. You don't really use the value like a void. There's no such value in Java. So if you try to print out the void value, it's not going to compile. If you try to assign the void value into something else, that also doesn't compile. Simply doesn't make sense. The only thing you can do is to call the mutator just by itself in isolation. That's the only way. For the accessor, it's kind of the symmetric way. So you can try to use the return value from the accessor, print it out, or you can try to use the return value from the accessor and assign that to something else, similar. Whenever you're expecting some value, you can make an accessor call. This one here is going to compile. If you simply just call the accessor as if it was like a mutator, it will compile, but it's not very useful because if this is going to return the BMI of Jim, you're not really using the BMI, so that's kind of useless, right? So that's more like a logical error, which is not going to really do what you really expect to do. Okay. All right. Any question from last time before I continue? We all good? Okay. So today, I just want to do more tracing and also, basically this course, will definitely involve lots of tracing to really help you understand OO when we talk about different concepts. Okay, so let's see here. Right, I want to start with just about using the this keyword, but let me just build it up, right? There will be like a story to tell. So let's say we have this. Let's say we have a person class, okay, and we have two attributes. We got weights and heights. And we have the so-called default constructor. You can see this constructor here takes no parameters. And then it has the body of the constructor being empty. So this one here is simply going to leave everything default value. Right? I'll just make a note here. You can see this is completely empty. So this is simply going to leave all the attributes, default values. So for example, the weight and height, if you call this constructor here to create a person, both of them will be just 0.0 because they're double. Okay? But I want to talk about this one here, about this constructor here. But before I go back to the iPad, I would like to show you a little bit on Eclipse. There's some very nice highlighting mechanisms supported by Eclipse or any IDE. I think it can nicely tell you what's going on. Okay, I'll show it to you. All right, so it's really the same class, right? We got person, and also we got weight and heights, and we got a default constructor. Let's say I want to define another constructor, and that constructor is going to use the parameter values to assign into the attribute value. That's what I want to initialize. Let's define that. Public person, okay? Okay, I'll put in the parameter in just one moment. So in the body here, starting from line number 17, I want to somehow use whatever value is passed to me, assign that value into weights, and assign another value into heights. That's what I want to do. So now I'm facing a choice. What name should I choose for parameter, right? So you got two choices, right? You know that one of the parameters, which I'm going to put in, one of the parameters is supposed to be used to assign into the weights. The other parameter, the second one, is also, its value is going to be used to assign into heights. So you got two choices. Either you choose the parameter name to be the same name as the attributes, or you can choose a different name. All right? You got two choices. Both will work. Let me choose the latter. Let me choose a unique name that's going to make things just work, without much confusion. So what I would do is, let me say here, double, it's a new weight, and double new heights. You can see the new weight over here has nothing to do with weights just yet. And also the new height here also has a different name with the heights, right? There's no clash, okay? That's one way to go. And now in the body of the constructor, I want to say whatever value I got from new weights, I'm going to put it on the right-hand side of the assignments, and I'll modify the attribute, right? So what I can do is I can say weights is assigned to new weights. And also I can say heights is assigned to new heights. All right, everything compile. And I can tell you this is one correct way of doing it. Okay, now please watch out. I'm going to show you the very important highlights. Okay, for example, let's say look at line number 17. So it's a variable assignments. To the left of the equal sign is a variable being changed. If I move my mouse over it, just click on that. Right? You can see the weight itself is being highlighted. Not only that, you can see at the same time, line number 3, the weight here is also being highlighted. In Eclipse, if you try to move your mouse over in a particular variable, it's going to highlight two things. Number one, it's going to highlight where that variable is first declared. In this case, it will be line number 3, right, where this attribute is declared. Number two, it's also going to highlight every occurrence of using that particular variable. In this case, we are using the weights attribute here in line number 17 as the left-hand side of the assignment. So that's why there are two highlights of this variable. So the point is, when I move my mouse over the weights, it tells me this weight here is really referring to the weights attributes that's declared in line number 3. Follow? Okay. Similarly, if I put my mouse over heights right here, that one there is also highlighting the declaration at line number 4. Right? So I'm really trying to modify, the two attributes. Let's look at the right-hand side. The right-hand side of the assignment tells me what value I'm going to use to assign into the left-hand side. Right? So now if I move my mouse over new weights, now you can see this one nicely highlights the new weights, the parameter declaration. Right? If I move my mouse over new heights, it highlights this one instead. Okay? Everything's kind of clear. All right? So if you kind of feel comfortable about the solution here, the good thing is you never have to worry about having any name clashes. There will be no confusion, right? Also by seeing the highlights, you can see clearly where is the attributes and where is the parameter. The only drawback here is you have to come up with some name over there. And sometimes people, like a more advanced programmer, they don't really like to take the hassle to really come up with extra names. The fewer names you can have, the better. Okay, that's why we want to show you another solution. Okay? But this solution is good, don't get me wrong. If you want to stick to this solution here for your lab or for programming test, nothing wrong. You're not going to lose any marks. However, for second solution, I'm going to show to you, you ought to know why it has to work in a particular way. Okay? So now I'm going to show you another one. Okay, let me just save this version here. Okay? Let me just say version 1. So no clash of names between parameters and attributes. I'll make the source code available to you so you can also take a look. Okay. That's version 1. Let's look at version 2. Okay, I'll show you the exact changes I'm going to make. Let's say for version 2, I do not want to create any unique names for the parameters. I want to somehow use, for example, the name over here. I want to indicate explicitly this is the value I'm going to use to change the weight attributes. So what I will do is I can say I change this one just to be the weights and change this one just to be the heights. So now on the right-hand side, of course, there's a compilation error. I got to change to weight and heights accordingly. So I will put weight here, and I will also put the height here. All right, that's version 2. Version 2, so choose parameter names the same as the attributes. However, version 2 here is logically incorrect. All right? Because we're modifying the wrong variables. Let's see why. First of all, let's now check the right-hand side. If I move my mouse over on the right-hand side of the weight, you can see weight here is now highlighting this way here, and this way over here. That tells me what's being modified on the left-hand side, the weight here, is not really referring to the attribute above. It's now really modifying this parameter over here. So we are modifying the wrong thing, right? Let's do one more. If I move my mouse over the heights over here, it's now highlighting to say the height here is really referred to the height in the parameter. Right-hand side is fine. But the left-hand side, you can see the height here is referring to just this parameter, not the attributes. So this version here is not good. And this is a phenomenon called variable shadowing. Okay, so let me just go back to iPad just to show to you, right? You ought to understand why this intermediate version is actually not actually wrong. Right, so now let me make it a little bit bigger. Okay, so you can see the weight, height, and height. All right, there's something called variable shadowing. So what you can think about conceptually is, let's say this weight right here is somehow creating some shadow, okay, that's going to block, right? So now you can think about just by saying weights over here. So this is now referring to the parameter weight. Not the weight attribute that we intend. All right? So similarly, you can think about this height here also creates some shadow, such that height here is also referring to the height right here. It doesn't really break through the shadow. So the follow-up question is, how do we break through the shadow? So I'll show you version number 3. All right? The answer is we have to use something called the this keyword. I'm pretty sure you maybe have seen that maybe in the first year. So there are several things we're going to talk about the this keyword. So this will be the simplest scenario. You use the this keyword to say, I want to refer to the attributes in the class, like a class level. Okay? I don't want to refer to parameter, especially when we have variable shadowing. So let's look at version 3. Okay? So let me just say one more thing. So wrong variables being changed because we got variable shadowing. All right, let's now look at version 3. Okay, again, let me just put this into comments. Let's look at version 3. Okay, for version 3 here, so this will be the right version. So I still got weights and height here, but now rather than weights, I'm going to say this.weights. and this the heights. Okay, so now let's check the highlighting. It will tell us nicely. This is actually the correct version. First of all, you can see if I move the weight, move my mouse over the right-hand side of the assignment weights, it's now only highlighting the weight here and the weight here, right? On the other hand, if I move my mouse over this weight here, it's not really highlighting the parameter anymore. It's highlighting also the weights at line number 3. So that means we're really modifying the weight attributes by the parameter value. Okay. Similarly, if I move my mouse over this height here, it's not really referring to this height here, but it's referring to the height at line number 4. All right. Is it clear? All right. Any questions? It is important. All right. So you ought to know all the 3 versions and which version work for what reason, and which version doesn't work for what reason. Okay. So version 3 is actually good. Using this keyword, allows us to refer to the attributes. All right. So we got all the 3 versions here. All right. So what you're supposed to do, let me just do a final annotation here. So if I actually try, for example, let's say if I say this dot weights and also this dot heights, so that will allow me to say this dot weights is really, is really referring to the weights right here. And this dot heights is really referring to right here. Okay, so without the weight and, without the this or with the this, it's going to make a difference. Question?
For version 1, is it okay to use the disk?
Very good question. I'm so glad you asked. The question was, in version number 1, is it okay if we also add this, even though it may not be necessary? That's the answer, actually. Okay. Yes, you can. Okay. In version number 1, let's see why it will be okay. Let me just comment out this one here. Okay. Let me go back to version 1, just to answer your fellow students' question thoroughly. Okay. So this one here, so you can see without the this, it's already working, right? So let's say we added this just to one of them. If I say this dot weights, so now you can see if I move the mouse over weights, it's still referring to the weight right here. So still the right attribute, so it's fine. It's just that unnecessary. Yeah. It's only necessary to add a this when you got variable shadowing, which is when the parameter name clashes with the attribute name. Other than that, it's not really necessary. However, I will highly recommend you try to add a this whenever you can. Whenever you want to refer to attribute values, use the this keyword. It's going to help also the tracing easier, which I'll show to you. Okay. All right. If no further questions, let's now move on. Okay. And this one here, I just want to show to you about how to trace the program. So this will be the way to go. Okay, so I'm going to show you just what I found to be the most efficient way to really, the most effective way to really trace a program. Okay. Oh, just before that, let me just pick one more note for you. It's actually on my notes. Okay, so this part here is what we said about variable shadowing. Okay, just to put the words here, it's called variable shadowing. Okay, that's one thing. Also, just make a note to remind you, you can use the this keyword to denote the context object. You will see this more clearly once we do some tracing, but I'll write it down first. The context objects. And this will be very useful when we do the tracing. Okay, I'll just put it here as a notes. Okay, so if you put this right here, it's going to refer to the context objects. In this example, in the constructor, the object that's being created. We'll see. Question?
Between each version that you use, is there really a difference, or is it really just preference?
I would say, yes. Of course, version 2 doesn't work, right? So I would say for version 1 and version 3, it's more like a preference. However, it's more common for as you get more experience in Java, people like version 3. Just use this keyword. So in that case, you don't have to come up with distinct names for your parameters. In some way, it's also very indicating, because if you make your parameter name the same as attributes, you're also indicating you really intend to modify your attribute, in the actual constructor. Yeah. Okay. But for this course, doesn't matter if you use version 1 or version 3. But you ought to know all the 3 versions, why they work, why they don't actually work. Okay, let's now talk about some tracing quickly. Okay. All right, so you can read this is actually some extract from the slides, but I'll just use a diagram here just to explain to you about the different components you want to include in your tracing. Let me also make it clear. So in this course, we are not going to grade any diagram you might draw on a sketch paper during the written test, programming test, or maybe the exam. So this is just something I would recommend you actually try to draw to help your tracing. Okay, but if you really want to adapt it to something simpler or more sophisticated, feel free. That's fine, right? As long as it can help you understand and also answer the question, that'll be fine. So let's now start with the box. So the box right here is really referring to some memory location, right? So it's somehow allocated for some objects specifically, okay? So you can think about this one here is some objects in memory. So objects in memory. And what type of objects? So immediately you can say the title of the box right here. Okay, so this is the type of the objects. So this one here is the type of objects. So we're basically saying this memory location here has an address. And the address is referring to a memory block that stores person-specific information, nothing else, just person. Okay? And then let's look at maybe the arrow and Jim over here. And Jim here is the reference variable. Okay? Okay, let me just say this. It is the reference variable, storing person address only. Okay, I can make further notes. Storing person address only, because Jim was declared to be a person type, right? And then this arrow over here, okay, this one here, this arrow, okay, that one tells you Jim currently stores the address of this particular person objects. That's why we use the arrow to tell you. So arrow should really point this way. You don't really have bidirectional arrow. You don't, right? So the, arrow, the direction here is actually also important. So you can think about this one here tells you that stores the address of. So the reference variable Jim currently stores the address of this particular person objects. All right. So let's look at the contents of the this person objects. Let's start with the attributes first of all. Okay. So this part here, right here, age, nationality, weights, and heights. Okay. So this one here, let me put it here. Okay. Okay. Right here. They are the selected list of attributes. And notice that I say selected for a reason. That means realistically, maybe you're tracing the objects of some class that has maybe 50 attributes. In that case, do you have to include all the 50 attributes in the box? No, you don't have to. So you want to somehow decide if I'm trying to trace my program, what would be the relevant attributes I want to trace for their values? Only include the relevant ones. So sometimes you will see that maybe for me to trace maybe about a BMI calculation of a person, I only need to include their weights and heights. I don't care about their name or nationality. You know, things like that, right? So it can be selected. Exactly what that selected list should be, you as a programmer who's doing the tracing, you will decide. And final part will be object-specific or instance-specific attribute values, which will be here. So it will be right here. Okay. So these values over here, right? So these are So these are instance specific. Attributes, values. Right? So for this particular person, so age is 50, and etc. Right? It's a very actually compact way to really trace the objects, as you create them and as you try to call methods on the object, as we'll see. We'll try to practice this right away. So this kind of notation will stay very much like this. There might be some very slight extension I have to make, especially when we talk about inheritance and maybe even when we talk about the equals method. I'll show you that extension, but I think this is good for now, okay? At least for your programming test 0, at least, okay? Any question about this notation here? I'll say try to practice that right away. The written notes about point and point collector, right? The written notes, you may actually want to try out this kind of tracing notation there just to make sure you're convinced about why the program will work just by drawing something on a piece of paper. Okay? It's a very good way to train your mind to be very logical and also patient. Okay? To really trace a program, you got to really faithfully execute the effects line by line on the piece of paper. Patience is very important. Okay? That's something I'll show to you when I trace programs in the class. Okay? All right, let's practice this right away. Before that, question.
Sorry, what does the purple text say?
Sorry, which purple? This one here?
Around Jim.
Around, oh, you mean this one? Or below or above? Okay, sure. Jim here is a reference variable storing person address only. Yeah, no worries. Yeah, just in case it's not really legible to you, feel free to interrupt. More than happy to clarify. All right, good. Right, we're going to trace 2 programs. Okay, so let me just make sure. I got one here, one here. Okay, good. So let's now try to do, I got about 8 minutes before halfway. Let's try, maybe about 10 minutes or so. We'll trace these 2 pages of programs, and then we'll take a short break. But let's do this one here. So it'll be a nice pause for the coverage today. So this page here is really about creating new objects, right? We kind of showed you last time about how to see the nice memory diagram there, but we don't need that anymore. Let's see what you can really do to do in a compact way. So we have the person class, we got weight and height, only 2 attributes, but in this case, I'm going to include both attributes in the box. They are both relevant, okay? And then we got our default constructor, and also we got our version 3, right? You can see I got weights, height, and using the this keyword, I'm also referring to these 2, right? That's something we just spoke about, right? Just a few minutes earlier. Let's now try to trace a small test case like this. And we're going to trace only these 2 lines about object creation. Once we have traced and drawn the diagram, we will be able to answer a question like this, whether or not maybe some Boolean expression should evaluate to either true or false. Right? So that's something we're going to see. It'll be very obvious once you have drawn the diagram correctly. So let me do the very first line in very much detail. I'll just show you once. Let's say this line here. Just this line. Okay, I'll put a star here. And then I'm just going to put it here. Let me write it out again. So we declare person type reference variable called Jin, which is assigned some value on the right-hand side. And we are using the new keyword. Whenever you see the new keyword, that means you're going to draw a new box. And then we call the constructor from the person class. Of course, we got 2 possibilities, either this one here or this one here. Let's say we're calling the second one. And then we're passing 72 and also 1.81. And if you remember, 72 is the arguments. Correspondingly, weight here is a parameter, right? So let's now try to see how this one can be understood. So I will break it down into 3 phases. So phase number 1 is about the decoration right here. Okay, I would say that's number 1. And phase number 2 is about executing the new objects creation here. Okay, number 2. And then I got this final stage is about connecting the reference variable by storing the address, of the object being created. All right. So these are the 3 steps here. Okay. Okay. Let's see. Step number 1. We actually declares a reference variable Jim. Declares a reference variable Jim. that stores address or reference of some person objects. Of some person objects. All right, so for this one here, it's very easy to visualize. Just write out the name. Okay, that would be good. You can think about conceptually. When we try to declare Jim to be person, right? At the moment, Jim doesn't store any meaningful address. It's as if it's storing now. But we don't need to do that because as soon as we execute the whole line, Jim is going to store the address of this new object. So we don't need to say now at the moment. Sometimes you may have to, right? In some other occasion. So just do this one here, okay? And let's now talk about 2. For step number 2, what we do is we have the new keyword right here. That means we need a new box. Okay, let's put a new box right here. And since we are trying to call the person constructor, right? So that means we're creating an object of type person. So the title of the box right here is going to be person. And now on the left column here, we're going to include all the relevant attributes. In this case, I'm going to include both of them, weights and heights. Okay? So let me say W and also H for short. You also don't need to write out the whole name. As long as you understand what you're doing, I think that'll be fine. All right? So the weight and height will be initialized to some values once we try to step into the execution of this, which I'll do in a moment. Okay? So we got person, weight, and height attributes. And at this point, it is important for the object creation, you want to understand that, remember, okay? This object here really corresponds to the this that you actually write in your Java code in the constructor. I'll show you. But just remember, in the constructor, when you say this right here, you really mean this object here. That's being under construction, really. Okay? So let's now try to step into, right? This is 72, correspond to weights. 1.81 correspond to heights, right? So what we can do is you can, let's do this one here. So 72, 72. And replace every occurrence of weights by 72. And 1.81. So that will be 1.81. And this will be 1.81. You can notice that we don't really replace these two because they refer to the attributes, not the parameter, right? What about the left-hand side? The left-hand side here, this dot weight and this dot heights. So this dot weights is really referring to this object being created. It's referring to the weights field over here. And we are assigning that to 72. So this one here will be 72. And this dot height over here is really referring to this part here. And that will be 1.81. All right. And then when we try to execute step number 3, which is about just the equal sign, the variable assignments. So we're going to store the address of the new objects being created to the reference variable. Well, in that case, after storing the address into Jim, Jim is now going to point to this object right here. Right? Notice one thing here. Jim stores the address of this object. So we kind of use this arrow to refer to it. Jim itself does not contain 72. Also, it does not contain 1.81. Jim only contains the address of the objects, which indirectly contains 72 and 1.81. It's a very important conceptual distinction you have to make, right? So reference variable doesn't store the object contents itself. It only stores the address of the objects. All right. Let's now try to trace the second line very quickly, right? In a very similar way. This one here, I will just draw directly, okay? I'll highlight something you want to watch out for. So let's say we do this one here, this line here. So what we do is, let me just do it in one go. So Jonathan here. Okay, let me put it here. So we got Jonathan, the reference variable. is going to store the address of a new object, right? You can see it's another new keyword. So it's going to be a different box. But the box is going to be of the same type, person. Because you see person right here. Okay, we got the weights, we got the heights. We got the weights and we got the heights. And one thing I want to point out to you. So this object being created is now the this when you step into the constructor, right? So if you try to trace the constructor call right here, so this right now is going to be this object right here, right? So when you say this dot weight will be 7, so that'll be 65 and 1.67. I'll write it down. 65. So this will be 65 and also 1.67. 1.67 and also 1.67. So when you trace it, this dot weights will be this dot weights assigned to 65, right? So that'll be 65 and also 1.67. So you gotta watch out for what this really is referring to, depending on which line you're tracing. Okay, but you're really executing the same block of code, the same 2 lines, but this is going to be different. Okay, and then after this, Jonathan is going to store the address of this object right here. All right, so that's the final the final diagram we have. Let's try to answer these assertion, right? Let me just talk about one of them, maybe 2 of them. Let's say this one here. Jim not equal to Jonathan, right? So we are saying that, so when you say not equal to, we are basically comparing address, as we said last time. You can think about it in a different way. From last time, we said Jin is storing different address as Jonathan. That means Jin is pointing to a different object as Jonathan. So now Jin is pointing to this object right here. That's what Jim really says. And Jonathan here is pointing to this object here. These 2 objects are different. Agree? Right? So this one here should be true. And assert true is going to pass. On the other hand, if you look at Jin equals Jonathan, that should be false. Because you say Jonathan and also Jim, they point to the same objects. Apparently that's false, because they point to different objects. So that should be false. And assert false is going to pass. Right? So this one here is going to be false. All right, any question about object creation? Yeah?
Can we say that the second constructor is the overloaded version?
You can definitely say, yeah, overloading. Yeah, so whenever we talk, yeah, okay, just so your fellow student talk about something called overloading. Yes, you can say that. Overloading, I can write it down. Method overloading. So we have the same name, which is constructor, but they have different parameter lists. Yes, and similarly will apply to methods as well. You have the same method name, but they just got different parameter list. Overloading. Yeah, we'll see another thing called method overriding when we talk about inheritance. Just make sure you don't confuse with them. All right. So we got method overloading and also method overriding. So these are 2 different concepts. All right, let me trace this one here very quickly, and then we'll take a short break, okay? This one here. So what we do is we're trying to kind of combine object creation and also some method call. So this will be a call to accessor, this will be a call to mutator, and also call to accessor again. Let's see how things will change differently, right? This pattern here, we also have seen that in the, I think in the very first OOP review lecture. So now we're just making things more precise, right? Also have some code besides us. Let's now try to do these 2, okay? This one here is going to create Jin, storing the address of this object here. And we got 72, 1.81. 72, 1.81. And the tracing of this we already did in the previous page, so I'm not going to repeat. The second one there, we have Jonathan, right? He's a different person. So what we have is Jonathan storing the address of this different object here, and we got 65, 1.67. 65, 1.67, right? About these two lines. So now, let's see how the context object here, right? So let's see this. If you look at the next two lines, we're calling the get BMI method. Get BMI here, and also get BMI here. So they are basically referring to the get BMI method here. And I deliberately try to make every reference to the attribute value using this. May not be exactly necessary, but it's actually good for our tracing. So you can see that this BMI here is actually just a local variable, so I don't need to say this. But the weights and heights, I all say this dot, and this dot, right? The advantage of doing this is once we know the context object of the method call is, once we know what it is, we can replace the this by the corresponding context objects. I'll show you. It's actually very useful. Let's say for this line here, gym.getBMI. So gym is the context object, right? It's this. So I'm calling this method here. I'm going to replace every occurrence of this by gym. Gym. And also gym. So the BMI that's going to be calculated is going to be gym.weights, gym.weights. So 72, based on 72 and 1.81. So it's going to be gym's weights divided by his the square of his heights based on these two numbers, right? You can double check. The number is going to be this once we calculate it, right? And then when I try to do the next one, Jonathan.getBMI, it's basically going to use the same formula, but we're going to plug in different numbers. How do we do that? So if you try to step into this method call again, so every occurrence of this is going to be Jonathan. Okay, so this will be Jonathan, and this will be Jonathan. So the same formula, but it's going to be Jonathan.weights and also Jonathan.heights, using these two numbers to calculate the formula. Right? So this number here is going to be something different. Okay, you can double check. Okay? So we're calling just the same method, getBMI. However, the result that's expected will be different, simply because the context objects that will replace this will be different. So that's why, the value calculation will be different. Let's do one more. Let's say here we have gain weights. Gain weights and gain weights. So this method right here. So what we have is, for example, let's say gym.gain weights. That one there, when we execute this method here, every occurrence of this will be replaced by gym. And will be gym. And the amount is simply 3. Okay? Actually, they will be the same. Let me just do a little bit more efficiently. So 3 here and 3 here. It's going to be just the same for both method call. So this will be just 3. All right? So when we execute this line, it's going to be gym.weights right here. It's going to be current weight plus 3. It's going to be updated to 75, right? So that one there is going to be 75. Similarly, when you try to trace this one here, Jonathan will now be the context objects, right? Jonathan here, right? So when you execute this one here, so let's step into it. So Jonathan.weights is referring to this. Its current value plus 3, so 68. So after these two lines, as you can see, we are adding 3 to just the weight attributes to different context objects, right? But you ought to know which one modifies which. Finally, if you try to trace the same getBMI method, right? So getBMI here, and also getBMI here, right? Let me do a little bit more quickly. Here, we have the gym context objects. So that means we're going to recalculate the getBMI, but now it's going to be based on 75 and 1.81, as opposed to 72 and 1.81 as before. So if you compare this gym.getBMI and this gym.getBMI, they are of different numbers, simply because one of them is using 72, the other one is using 75. Right? And similarly, if you actually try Jonathan.getBMI, so now we're going to use 68 and 1.67. It's going to give us a different value right here as opposed to this value here from before. So this pattern here, we actually spoke about in the very first lecture about the OOP review, but now we just make it even more precise about tracing. All right, any questions? So these two, just make a quick summary and I'll take a question. So these 2 pages really summarize about what you ought to know for the basic tracing about object creation and identify where the this is when you do object creation. And also when you call method either accessor or mutator, how you can replace the argument value and also replace the this by the context objects. So everything else will just take some patience and precision, right? Question, please.
What's the 0.01 argument in assert equals?
Okay, good question. That one there, you might be briefly touched upon, maybe in the tutorial, but let me just explain that. So let's say this one here. Let me use a different color. Okay, this one here. And you're basically asking about 0.01. Okay, so whenever you're trying to check the return value, that's this double, right? So briefly speaking, computer is binary. However, when you say 22.893 is base 10, so base 2 and base 10 in theory can never be compatible with each other. So we have to specify something called tolerance. I'll show you exactly what that means, okay? So let's say if I say assert equals, let's say if I got some double value x, and then I got another double value y, and 0.01, okay? So think about these 2 values are simply double. And double here. It would be as if you're checking for assert true. And there is some Boolean expression over here. So let me write it in more like a math, a little bit easier for you to see. We're saying that x and y are kind of allowed to be not exactly equal, but their difference should be no more than 0.01. Okay? So you can think about, put it this way, the simplest way. You can think about x minus y should be less than or equal to 0.01. Okay, and the 0.01 here is called tolerance. Okay? I think maybe in your other maybe physics or maybe other hardware course, you may have heard about something called epsilon, like a tolerance. Okay. All right, any other questions? All good? Alrighty. So why don't we take a short break and then we'll take attendance. All right, so before the break, we spoke about how you can trace object creation and also method call. So let me now get to slide number 50. It's about reference aliasing. So I'm going to cover some basic stuff, give you some definition, do some very simple visualization to understand what aliasing really is. And then we do some also simple exercise to prepare you for some more advanced exercise, which I already told you how to find it. And then you really want to try it maybe before Thursday class, and then we'll do it together. All right. And I'm just gonna, you can read the slides, but let me just switch to directly the example. Okay. So we got 2 blocks over here of code. So this one here is just about primitive. I want to trace this one very quickly, but you will see the pattern about tracing reference aliasing will be very similar about how you trace primitive. So you do have some consistency there. So you don't really have like a 2 distinct way of tracing. Okay. So let's start with this, right? For this one here. So what we have is we declare I to be an integer, and then the value should be 3. So you can think about we just got a box right here, and then I has the value 3. All right, straightforward. And this one here, we say j is initialized to be some value. But the value here is not like a 3 here. It's saying whatever that is stored in I. So what we're doing is we are copying the value that is stored in I and store that into j. That's what we're doing, right? So what we have is we got another box over here, and we got j. Okay. So think about we are basically copy what is stored in I and store that value to j. That's what we're doing. Right? In this case, copy 3 and store 3 right here. Right? So we got 2 copies of the value 3. And then we got another one. We say k is 3. So we got the variable here. So we got k here, and we got 3. Right? So we basically got 3 variables here. So we got the same value 3. 3 copies, right, in all the 3 variables. And of course, you can do some comparison. So if you say I equals j, right, 3 equals 3. So that one should be true. That one should be straightforward. And then you can say k and I, 3 and 3. K and j, also 3 and 3, right? And this one is also something you're supposed to know, right? Remember, that's the AND operator, right? So it will be true if both sides are true. So in this case, it will be true. So this is actually true. This is also true. That means this AND here is also true. So I believe there's a truth table for the AND operator. So that's something you may want to go over as well on your own, right? So in case you got asked the question. Okay, and then let's now move to reference right here. So let's assume we have a class called points, and in the point class we got x and y attributes, right? You will see the point class also in the slides. Okay, so let's try with the first one. Okay, first line. So let's say this is my line number 1. Okay, and that one there we know pretty well how to do it, right? So P1 stores the address of an object, like a box, and the object has the type point. Okay, so guys, please, all right. Okay, and then we have point right here. And then for the point class, we got x and y. All right, so here we should really get 2 and 3. So 2 and 3, okay? So this is good, very similar to how we created Jim and Jonathan from before. But we're now going to look at this line right here, all right? What does this really mean? First of all, you can see that the right-hand side here has no new keyword. That means we are not supposed to draw another box, first of all, right? So what we do is somehow, let's think about what this one really means. We say we're going to copy whatever that's stored in I into J. We're doing something similar. We're going to copy whatever that is stored in P1 and store that into P2. What does P1 store? The address of this object here, right? So if I store the address of this object here into P2, what does that mean? That means P2 is going to point to the same objects. Agree? All right, so that's why you really want to somehow remember the analogy. The way you kind of work out the variable assignments for primitive similar to reference variable, except that we are copying addresses as opposed to primitive value. All right? So now in this case, so what we get is we got P2, and it points to just the same objects, right? Let me say it one more time, but you can write it down maybe later, just in case you missed that. We're saying we're going to store whatever that is stored in P1, which is the address of this object here. Store this object's address into P2. That means P2 is also going to point to this object here. That's what we're doing. All right? So after this, when you say P1 equals P2, we're basically comparing if they store the same address. Another way, we're saying, is P1 and P2 pointing to the same objects? Indeed, they are, right? So this one here should be true right away. All right, let's now move on. And the next line, we have this, P3, right? You can see this line here, we have the new keyword. So that means we're going to draw one more box, right? So that one there is going to be P3 simply points to an object of type point. And that one there also has x and y right here. And it's going to be 2 and 3. 2 and 3. One thing to say right away, you can see we got 2 different objects. They are in different locations in the memory. However, their contents, 2 and 2, 3 and 3, happen to be the same. So there are two different objects, but their contents are somehow the same. So that will be the topic for equals method for later. All right. So after this, so let's now do some comparison quickly, right? How about this one here? When I say P3 equals P1, false. Okay. So P3 points to this. P1 points to that. Different objects. So that one should be false. And P3 and P2? False. So P3 point to this. P2 point to this. Different objects. So that one there is also false. And this operator here is the OR operator. Right? So the only way to make OR false is when both sides are false. So in this case, we got false or false. So this one here is going to be false, specifically. All right, you can also try that out for this one here, right? I'll just show you one of them. P3.x, P3.x, P1.x, P1.x, 2 and 2, right? Right here. So we got really the same value, but I can go on with the comparison. So once you have drawn the objects, you will be able to compare not just the addresses, but also their contents, right? All right, any questions? We're good? Let me just write one thing for you, okay? So that can also help. So this equal sign here, I'll put star star, okay? So here, basically, we are saying after this, after executing this variable assignments, P1 and P2 point to the same objects. The same objects. All right. All right, any question here? We good? Okay, good. So let's now do one more example. So this will nicely prepare you for the more advanced example, which we're going to do on Thursday. Okay, so this one here. So this one here, we don't really touch any reference variable. That's something I want you to try. But I want to show you the loops and also array. So that'll be a nice way to kind of review these two concepts first. So we don't have them as obstacle for Thursday. All right, let's take a look at this, right? Okay, I'll make it a little bit bigger. Right? That should be good. So what we can do, let's say we try with the first three lines right here. All right, rather easy. So we got I1, I2, and I3. Okay, so we got I1, I2, and also we got I3. Oh, sorry. There we go. Okay, 1, 2, 3. 1, 2, and 3. Okay, straightforward. Nothing else to say. And then you can see that we got two arrays over here. We got numbers 1, and also we got numbers 2. Okay, and for both of them, you can see we got square brackets, right? So that means we got arrays as opposed to a single integer. So for both of them, the way to interpret this is this. So the variable, the reference variable, stores the starting point. The starting point of an array, where each element is simply an integer. An array where each element is an integer. Okay? But we've got to visualize it. It's not exactly possible to really express that precisely using English words, but we'll visualize that. Okay? So there are two ways for you to initialize an array. You can either use this expression here, or you can use like a new creation, just creating a new array. Okay? Let's see the first one. So this one here is telling us numbers 1 is going to point to the beginning of some array. What's the size of the array? 1, 2, and 3. Right? You can see exactly like how many elements there are. Or you can use some, you can simply say 0, 1, and 2. You know, the different indices. We got 0, 1, and 2. We got the length of the array will just be 3. So what we have is, so let's say numbers 1, I'll say n is 1, okay, numbers 1, points to the beginning of an array of size 3. So we got 0, 1, and 2. Okay? And at index 0 is going to be the value of I1. So think about we're going to copy the value that's stored in I1 into index 0. And also copy what's really stored in I2 into index 1. Copy what's in I3 into index 2. Right? So what we got is 1, 2, and 3. These values. Questions about this? So if you want to make a longer array, you just make more comma, it's a comma separated list. So you can just make this list longer. And this one here, it's doing something very similar, but we're saying the following, okay? So we are still creating an array. Let's say this one, n is 2, okay? It's pointing to the beginning of some array. But now in this case, we're saying using the new keyword. And what's really passed over here is the size of the new array that we are creating. What's the size? So the size is going to be the same as numbers 1.length. What's numbers 1.length? 3. Agree? And is 1.length is 3. So you can think about this part here is really 3. So that means we are creating an array right here of length 3. Which means we got indices 0, 1, and 2. And if you remember, the maximum index of the array is going to be its length minus 1. Right? That's something you learned from the first year. Now the question is, in this notation, what's going to be the value? Right here. Because in some way, we didn't really say, for example, like before, like I1, I2, and I3, right? I1, I2, and I3. We didn't say that. Default values, right? Exactly. Okay, that's very good. So now in this case, what should be the default value? Should it be null? 0. Okay, very good. Because you're a fellow student from yesterday, section B, they had some confusion there. So you can default value, how do we determine? You can see for numbers 2, every element in the array is going to be integer. So it's not going to be null, right? Default value, right? So what we got is 0, 0, and 0. All right, good. And let's now try to understand about the for loop right here. So we're going to do some change, okay? And I want to let you guys stare with this for loop over here for just 1 minute, okay? Not much longer, okay? Just 1 minute. And typically, if you actually try to trace a for loop, right? Number one question you want to ask yourself, how many iterations are there? Okay, sure, whatever number you think. Number 1, okay, so you want to think about it, number 1. Number 2, for each iteration, what's going to be the value for the loop counter? And how exactly is the loop counter I value is going to be used to do some change? Because a similar pattern is going to be repeated. That's exactly the purpose of writing a for loop, right? Okay, stare at that just for a few more moments, and then we'll look at that together. And a quick reminder. Numbers 1.length, right, is 3, right? So this will actually help you decide what's going to be the maximum value of I that's going to be used in the last iteration, right? All right, question 1. How many iterations? 3, agree? Okay, good. Now, second question. What's going to be the value for I? 0, 1, 2. What about when I is equal to 3? It's going to make the, okay, very good. Okay, you guys are good. Okay, let me just repeat, just in case your fellow student may not be following. Okay, so the way I'm going to trace it is like this. The value of I is going to be starting from 0. It will be incremented by 1 each time. Of course, sometimes it may be incremented by 2, incremented by 3, depends. Okay, so it's going to be 0, 1, 2, and when we increment to 3, okay, so this is the place where you got to be careful, right? Because there's a Boolean condition right here, right? To say the current value of I, which is 3, it should be less than the numbers 1.length, which is 3. But now if you evaluate this expression here, it's false. So I being 3 is not going to cause another iteration. So that means only 3 iterations. The very last value here is going to be false. So that's really when you exit from the loop. So you don't have an infinite loop. False. So that means exit from the loop. All right, that's good. And then 0, 1, 2. So what we do is we're going to use this pattern here, instantiate I here, well, maybe replace I by 0, 1, and 2. All right, that's now the first iteration. Okay. The first iteration, we're going to say numbers 2 at index 0 is assigned to numbers 1 at index 0, right? Like that. What does that do? We are modifying numbers 2 at index 0. We are modifying this value. We're going to copy over numbers 1 at index 0. Copy this value over here, right? That's what we're doing. So we're copying this value here and replace it for this value. So what that does is it's going to replace 0 here by 1. Any question about the first iteration? Because once you understand this, for the later iterations, same pattern, it's just different locations are going to be used. All right? All right, second iteration. The same pattern is going to be executed right here. So n is 2 at index 1 because I is 1. N is 1 at index 1. So we're basically modifying n is 2 at index 1 by copying over n is 1 at index 1. So copy this one over, right? So that means this will be 2. Right? The final iteration is going to be right here. Okay? So n is 2 at index 1 is n is 1 at, 2. Beg your pardon. Yeah, just be careful whenever you're doing tracing. Okay, 2 here. And then n is 1 at index 2, right? So this one here, n is 2, 2. Copying over n is 1, 2, 3. So that will be 3. So after executing this loop here, we got also 1, 2, and 3. We just basically make ns2 look just like ms1. The challenge we're going to have is when the individual element in the array is not primitive value anymore. Instead, it's going to be address of the objects. That's where the challenge is. But I want you to try before Thursday. All right, a few more lines. What about this line here? When we say numbers 1, okay, numbers 1 at index 0, and then assign 4 to it, okay? That's what we do. And we want to figure out 2 values over here. What is numbers 1 at index 0? 4, okay, very good. Obviously, right? And also numbers 2 at index 0 is 1. So we got 4 and 1. All right, so make sure you actually review this kind of loop pattern here. Of course, things might get a little bit more complicated by modifying different parts of the for loop. And before Thursday, please make sure you also go over that particular exercise over here. Give me 1 minute, I'll be done. Okay, I'll let you go earlier, I promise. Okay, give me 1 minute. So if you look at this one here, it's going to involve about person object being stored in the different element of the array. So really give it a try. Even if you guys struggle, know exactly where the struggle is. So when I go over this one with you from beginning to the end, you will appreciate it a little bit more. Thank you so much. I'll see you tomorrow for the mock-up test if you want to come.